All right, welcome back to Lag Demon Programming in the Compiler Design course. So we've built this compiler, a very simple compiler. Excuse me. Where is it? Yeah, this is it. For this very simple kind of functional language, and we're going to add more capabilities to this as we move along. Excuse me a moment. But we want to be able to test it and use our test.fng file here for our fungin file and run this code, or at least run it through the parser and make sure there's no errors, make sure that we set everything up right. So what we're going to do is go down here, find main, and I'm just going to kill this main function. And let me check my notes here. Here it is. We're going to pop in a new main function. We're going to have to include some things. I'll just put this down here. It looks very similar to that one, but I didn't want to mess with this one because it's calling our command line and stuff. This one's just going to be calling our things that we need. So right now we need this. And this. I think that's all we need in here. We need to include this and have this funcle in, except it's got to be oh yeah, because it's fungin parser.hpp. So what are we doing here? Do we even need... Oh, that's right. That's going to be in... That's going to end up in build fungin for now, until I can figure out this pathing. We're going to go build fungin parser.hpp. Later we'll set up a function in such a way that we don't need to do that, but this will work. I believe it'll build now. Oh, no, it didn't. Oh, I gotta fix the main function. This has to be... Darn it. What is that? Yeah. Typical FGON fungin parse make fungin in. Why don't we have a fungin in? Because I didn't change it up here. Okay. It's late at night. What's wrong? Undefined reference to fungin in, because we need to link that library in our main. Main does. So it's in here. Command line dungeon and fungin. Now it really doesn't like it. clear. Oh yeah, and utils. Is it utils? No, we can't do it that way. I think I've got to load. Yeah, it's here. We've got to load pound include utils.h. And then we got to go back to here and add utils. There it is. So now we can go game fungin slant test.fng. Let's go back to main. Okay, it looks like it did in fact parse it. Let's change this to fungin so it's putting out the right name. Make. So no apparent errors. Let's check that by putting some gobbledygook in here. Oh, we didn't need to do a make. Well, it probably saw that as a function call, or thought it was a function call. So let's put some arbitrary symbols that don't make any sense. See if we can get an error out of this thing. So there we got an error in file on line 6, syntax error, unexpected times. And if we do the same thing, we'll create another error at another location and show that the getting multiple how it gets multiple errors. So run this through, and so it found 2 of the errors before it apparently gave up here. Probably needs something like that here. Now it's showing 3 errors. So it combined this all became 1 error without something good in between it. It just saw a single error out of all that. So you can see here we get multiple errors, and we're still got a funkle in there somewhere. Instead of fungin. It's got to be up here. Fungin. Yeah, there it is right there. So let's make this fungin. It's a functional dungeon. Fungin. Okay, fungin error in file. We're not recording the file because we're doing that here. Excuse me, we're doing that over here. Yeah, and I've got no here in main. Yeah, we're opening the file here, so it's not recording the file name up there. We need to put a function in there to call and all that. We'll get to that later. This is enough to test it. We know what file we're opening right now. And this is just test code anyway to show that the parser's working. So let's go get the errors out of here. And now what we want to do is start constructing. Let's double check this. Yep, no errors. So now we want to start constructing our abstract syntax tree. which is going to give us the types that we need in our system to start piecing it all together as an abstract, as a tree. So we're going to work through this little piece at a time here. So here in Fungin, we're going to create a new file, and we'll just call it fungin_ast.h, and then we'll make this here. This there. Okay, so what do we need? Well, we need a couple of things. We kind of need, for our AST, we're going to need a couple of pieces, but we're only going to work with the basic AST at the moment. Rather than working with the context and the visitor and all that, but we need to include the visitor at least as part of our system here. So, and actually we'll fill in the context a little bit. So I may organize this just a little bit. Hell no, the context needs to know about the AST. The visitor needs to know about the context. Okay, we can do this. So we need just a couple of basic things here for includes. These are simple and straightforward, OStream and vector. And I'm going to forward define a class called visitor, which we're going to define later on. And it's only so that we can have this visitor function in here. Okay. So let's think about a tree. So a tree needs to have a base class so that all the elements all of the individual nodes are based on that one class. So we're going to call this class, well, we'll call it node. Maybe I should call it FNG node. So this is the basic node that everything's going to ultimately derive from. And we need a couple of virtual methods. I'm just going to pop these in and a friend operator overload here. I'm just going to copy these in. So this is our visitor virtual method. We'll override this in each one of our things and put an implementation, but we won't actually put an implementation yet until we come back and define the visitor. What the visitor is going to be is an abstract class, a completely abstract class that we'll make an implementation of, and we'll make an implementation for analyzing the tree, making sure it's correct. We'll make another implementation for doing some of the optimizations we want to do, and we'll finally make an implementation of that visitor that emits code. And each one of those visitors will work in basically the same way. They'll just have a different function to them. This is a little mechanism that I set up. There's a virtual method that takes an OStream and returns an OStream, and it's a constant, an abstract method, and we'll override that for how we want to display each of our nodes when testing and troubleshooting. And then because this friend class is here, we can outstream our classes, and they will just call the node that gets passed in .out, and it'll call the correct node based on that virtual function. So we need a semicolon there. All right. So if we go over here and take a look at our Fungin parser and go down here to the bottom kind of, we need to think about what we need to start accumulating data about. Okay? So one of the earliest things in this that we need is an identifier. All right? So to speed things up, what I'm going to do is copy paste these nodes in one at a time and explain them and how they relate back to this. So the first thing that I really want to capture here is an identifier. Types are going to be certain types, and this is going to be a kind of a type as well. And I'll show you how we're going to handle that. But let's begin with, well, actually, let's begin with type. It's at the bottom of the list. I like to build languages from the top down, thinking about them in more and more specific ways doing this. But then when building the abstract syntax tree, I need to build it up from the bottom up and think about how each of these, because I can't build this thing until I know what this thing's producing and so forth. So we're kind of going to go backwards through it. So let's create our types first. And let me find that. All right. So for our types, we're going to have a basic enumeration, and we're going to put that in our AST. Where is it? There it is. Right here at the top. So this is an enumerated class of types, named types, and it's got int, float, string, char, byte, bool, record, enum, function, infer, which I will explain in a moment, and unit. Unit is what I told you. It means basically nothing. It's kind of like or similar to void, but you can't have a pointer to unit. You can't do anything with unit. Unit is literally nothing. Infer means we don't know what the type is yet. We've identified something. We're going to mark it as infer because we don't know what the type is during the compilation process. Wherever we see this infer type, our little inference engine we're going to build is going to try to figure out what that type should be. If it can't figure it out, it'll have to emit an error because it'll have to type everything. So these are our types. And we've got our first node. I'm going to put a little helper function in here, and this is for our printing things out, and this helper function simply can convert each one of these types into a string that we can read. Otherwise, if we just put this out to the stream, we'll get a number. Now, int will be 0, float will be 1, and so forth. This will print out type to string. We'll take a type and print out or give us back a string. So that's pretty simple. Okay. That's all I need out of here. Let's go back to, why did I lose it? There it is. All right. So we have our types. And so here in our, let me arrange this so that I can find them. Okay, here's, I don't need the, darn it, I don't need this anymore. I need the parser. I don't need the utils right now. I need the Lexxer. We can use that. I need the AST and that. We'll come back. I'm going to close main for the moment. That one, and we don't need the utils. There we go. That's a little easier to manage. All right. Here's our AST. Actually, I want to go back to our parser. Each of these, simply this type here needs to be of this type here, because that's what we're going to return with it, is the type. So up here in our union, we need to create, we also need to include our AST file, and it needs to be above the parser HPP pound include, and it's going to be fungin underscore ast.h. We need that. And then here we need types, and we'll call it type. And down here we're going to create this token, or excuse me, we're going to create a type. And don't confuse them, that's a keyword, type. Type is our type up there, and type is our non-terminal. And they're completely separate things, so here's type. And unit also has to be a type. So we'll do that as well. Type and unit. I brought unit separately because it's used separate than the general type. It's used for specific purposes. So it's still a type, but it's separate. So for unit, we can simply go $$ equals types, : unit. And then right up here, we can, well, let's just copy that. And we'll just change it. Go out here a ways, put each of these in here. And then we'll just change them to their appropriate type. Great. Hit the copy by mistake. So this is going to be float. String. Character. Byte. Bool. Record. And enum. And we've not done the function in here because it's not a keyword for a type. It's a special handling situation just like this, and we'll get to that eventually. So this is simply going to say that type is going to become one of these new kind of values rather than these tokens. I could have reused the token, but that means that other things that need access to this also would have to have access to this compiler file to get these, and I don't want that, so I'm translating it over to these. This is cleaner from a organizational point of view. I could include that, but it's not right to include a bunch of stuff that those other systems don't need, like all the compiler code, just to get these enumerations. So let's build that and make sure it works. I'll probably get an error. I did something wrong. Node. Oh yeah, I changed this, didn't I? This has got to be an FNG node. And types does not have a type. Okay, how did I manage this? Function.ast.h enum class types. Okay, let me take a look. What did I do wrong? Oh, I know why. Over here in the Lexxer, we also have to do this. We have to include this. It doesn't pick up your includes, and this Function Parser HBP needs that. So we have to include the function_ast.h here as well. I believe this will almost compile, and then we also have to do it in main. And where's our main? I closed it. There it is. And here where we've got this, we also need to include why isn't it like that? It's got utils just fine. No such file or directory. Why? We're in game. Include if it sees utils, which the utils are in, well, I'm looking in the wrong place first of all. Yeah, it sees utils .h just fine. Oh, I put it in the wrong place. This belongs here. Now it'll see it. Let's go back to main. There we go. I got to keep that build directory closed. It confuses me. I see a folder in it and don't realize it's the build directory. You know, it's grayed out. I removed it with the git ignore. I realized that I hadn't put that in, and it was so there we go. Game and there, that compiles without any errors. So there we go. This is how we're going to work on building up our AST, one node at a time. This has been a little bit long so far. It takes a little time to get these things set up and positioned, but now we're in a position to start building out nodes. And so we'll do those one step at a time in the next video. We'll go right up this line here, and we'll build each of these nodes one after another until we have the whole thing built out and it's producing a node. And we'll be able to print those nodes out using our little print routine so that we can see that the nodes are being built properly and everything's being hooked together properly. So that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.